In this lesson, we will talk about what it takes to create a proper hypothesis test. We define hypothesis test as the formal procedures that statisticians use to test whether a hypothesis can be accepted or not. A hypothesis is an assumption about something. For example, a hypothesis about family pets could be something like, the average number of dogs per American household is 2. Hypothesis testing is about testing to see whether the stated hypothesis is acceptable or not. During our hypothesis testing, we want to gather as much data as we can so that we can prove our hypothesis one way or another. There is a proper 4-step method in performing a proper hypothesis test. 1. Write the hypothesis. 2. Create an analysis plan. 3. Analyze the data. And 4. Interpret the results. Let's take a look. But first, let's meet Sam. Sam has a hypothesis that he wants to test. Sam works as a researcher with the National Food Administration. He is the one that goes out and tests the food that we eat to make sure that it is safe. Let's see how he follows the 4-step method. The first step is that of writing the hypothesis. You actually have 2 hypotheses to write. One is called the null hypothesis. This is the hypothesis based on chance. Think of this as the hypothesis that states how you would expect things to work without any external factors to change it. The other hypothesis is called the alternative hypothesis. This is the hypothesis that shows a change from the null hypothesis that is caused by something. In hypothesis testing, we just test to see if our data fits our alternative hypothesis or if it fits the null hypothesis. We don't worry about what is causing our data to shift from the null hypothesis if it does. Keep in mind, when writing your null hypothesis and alternative hypothesis, they must be written in such a way so that if the null hypothesis is false, then the alternative hypothesis is true and vice versa. What does Sam do here? Sam's null hypothesis is that all meat that is sold to supermarkets is less than 48 hours old. Sam's alternative hypothesis is that all meat that is sold to supermarkets is more than 48 hours old. As you can see, if the null hypothesis is false, then the alternative hypothesis is true. The second step is to create an analysis plan. This involves deciding how to read your results to know whether your null hypothesis is true or your alternative hypothesis is true. Usually, this involves analyzing just one single test statistic. There are 2 ways to read your results: p-value method and the region of acceptance method. The p-value is the probability of observing the desired statistic. If this p-value is less than the significance level, then the null hypothesis is not valid. The significance level is the probability of making the mistake of saying that the null hypothesis is not valid when it actually is true. The region of acceptance is a chosen range of values that results in the null hypothesis being stated as valid. For this step, Sam decides to analyze his data using the region of acceptance. The statistic that Sam decides to use is the amount of hours the meat is at that is being sold to supermarkets. Sam goes to various meat providers and checks to see the age of the meat that is being sold. He then analyzes this statistic to see how many meat providers are shipping meat out under 48 hours. The region of acceptance is 99% or higher. This means that if 99% or more of the meat producers ships out their meat in time, then the null hypothesis is valid. The third step is that of analyzing the data. It is the putting step 2 into action.